Yes, thank you.
Good evening to all. So it's my privilege to introduce our esteemed speaker, uh, Mr. Gopalakrishna Bhatt Kakunji, a distinguished technologist, entrepreneur, and also industry leader. Mr. Gopalakrishna Bhatt is currently serves as a CEO and also managing director of Kakunji Software Private Limited, where he has been providing visionary leadership since October 2015. And under his guidance, the organization has made significant contributions in the areas of software development, embedded systems, and innovative technology solutions. He has over a decade of rich industrial experience. He began his professional journey with IBM India Limited, Bangalore, where he worked as a technical engineer specializing in embedded systems. He served as a senior system engineer at Infosys Limited, Mangalore, contributing extensively to enterprise level software solutions. He is also a proprietor of electro instruments industries and embedded systems and robotic product manufacturing unit. He has completed his BE in Electronics and Communication Engineering and MBA in Finance. He has four patents to his credit, and he is also recipient of many awards such as Innovative Startup from Startup Karnataka, Best Research Product Award from ATAL Incubation Center, and Innovation Automation Product Award by the Indian Welding Society, Best Entrepreneur Embedded System Category Award from NITK STEP. He is also author of MathWorks File Exchange, and with his vast experience and passion for innovation, we are confident that the today's session will be highly enriching and inspiring. Thank you, sir, for accepting our invitation and to deliver the session on IoT in smart agriculture. Thank you, sir, and I welcome you, sir, for this Atal online FDP on innovations in smart agriculture. Over to you, sir.
Good evening, everyone. First and foremost, I would like to express my sincere gratitude to Canada Engineering College for inviting me as one of the resource person for this uh, IoT in smart agriculture session. Uh, we all know that we are living in the era of artificial intelligence, Internet of Things, then quantum computing, many more such advanced technologies. So IoT is one of the most widely used technology among them. So Internet of Things is one of the highly applicable concept in the field of industry, agriculture, healthcare, everywhere. So today's title IoT in smart agriculture. So first of all, uh, before starting the session, I would like to give uh, brief idea about the today's agenda. So first, we are going to discuss about what is the one technical definition, one proper definition for IoT. What is IoT and how it works? That we are going to discuss in the first point. And the second point, we are going to discuss about how to implement an IoT system. What are the essential components of IoT system, Internet of Things system? And the third point, we are going to discuss about different IoT development boards available in the market, the low cost board and higher cost boards, expensive boards. And the third one, the different area, the applications of IoT, where and all IoT is using now, the fields of IoT, the areas, the case studies, and the fourth point, how to implement one small IoT system. And we have one live demo also. So we are using ESP32 development board for this. The live demo also available for that. And after that, we are going to show our few products And in that different modes like station mode, access point mode, server mode, different modes of IoT we are going to discuss. And after that, I'm ready to answer your queries. So let's start the session. I think this PPT is visible for all. Am I? Can I continue?
Yes, visible,
Yes.
sir.
Yes. So first, introduction to IoT. See, as we know, IoT, if you search in any AI tools or in Google, you may get a different definition for IoT. So always we expect simple and easily understandable definition. So from my experience, it's my own definition. Like Internet of Things is nothing but it is a network of embedded system integrated with the sensors, relays, actuators, cameras, which can control a device or which can real-time monitor the device through internet by using any application. It may be a web application or mobile application. So this is the block diagram which represent easily we can understand what is uh, Internet of Things. See, one side we can see hardware here, one side, the electronic embedded system. It is integrated with the sensors and other modules. Even we can use cameras also. And basically, Internet of Things has only two functions. One is controlling the device, and second one is monitoring the device. So only two functions we can perform using IoT system. And here in the software side, we can see user applications. It may be mobile applications, web application. So any application, internet based applications. And the third, the main point, the middle point is nothing but cloud or server, which gives internet, which connects easily connect to internet. And so now device that should connect to through cloud and cloud to application. So basically two functions we can do: control a device. Now user will, for one flow I can explain you here. User will give some command. So from application to cloud to device. And now, for example, here just imagine one bulb is connected to this electronic device. Now user is sending one data one, and that is go to that will send to the cloud. And in cloud, if you want, you can give database also. From database to the device, IoT device. And if you when it comes one device, the device will accept the device will receive the data, and it is connected. The bulb connected to the device will switch on. And again, when user gives zero, same flow, and bulb will switch off. This is controlling part. Now just imagine some sensor, now DH11 temperature sensor, or any other sensor, now MQ135 air quality sensor. So any sensor is connected to this embedded system. Just imagine that. So here analog and digital interface is there. So we can the controller which is connected to embedded system will receive the data and send to cloud to the user application, and user can monitor the values. Now, for example, if we connect a temperature sensor, DH11, we can see temperature and humidity of the where this embedded system is placed in that place, in that environment, humidity and temperature, we can see this. This is the basic definition of IoT. So if you go to deeper search, we can see the layer by layer, like essential components to build a IoT system. So it must need one embedded system, which must has Wi-Fi or Ethernet port, because using that we can connect internet to that embedded system device, and sensors, relays, and other modules we can connect as per our requirement. And internet network is required, and one gateway with security is required. Cloud or server is required. And you see here two option is there. One is global network, like now anywhere in the world we can sit and control and monitor. That is one option. One is local network. So in two way we can do it. So in global way, this cloud and server is must. Otherwise, in through gateway itself we can control it. And the middle part, network and gateway, and the software part, user application. As I said, we can give web application or mobile application, anything. So these are the essential component to build a IoT system. So this now our next point, the different boards available in the market. So one of the cheapest board available in the market is ESP32. So in that Wi-Fi, the about board we are going to discuss in the next slides. And Raspberry Pi, this is also one of the most popular board. It is like one tiny system. We can install the OS, and it has different the RAM. Everything is more compared to ESP32. And next board is Arduino Nano 33 IoT board. These are new board. Even in this also Wi-Fi, Bluetooth, that things is available. And Node MCU. This is one old board. In that only Wi-Fi is available and only one analog pin input is available. Compared to ESP32, if you compare Node MCU and ESP32, ESP32 is better. Cost-wise, both are same. But in ESP32, we have more analog and digital pins compared to Node MCU. And second one is the fifth one is BeagleBone Black. This also one tiny computer like Raspberry Pi. So that even using this also we can develop IoT systems. And Jetson Nano, this is the higher end higher end boards, even industry grade boards, Jetson Nano and Qualcomm Arduino. These are higher end boards. So many more boards are available. These are the highly useful boards in the market, even for DIY, even for industry. So these are the IoT development boards available in the market. Now IoT applications. So as I said, IoT is now IoT related applications we can see in every field. If you take defense to healthcare to automation industry, defense to healthcare, everywhere we can see one or another form of IoT applications. Now, a few case studies we can discuss here. First one is IoT enabled real-time healthcare monitoring system. So we know that healthcare is one of the important field, important industry. So like in that, one example is IoT integrated smart robotic surgery system. Now, for example, doctor is there in USA, patient is there in India. Doctor can do robotic surgery through internet. So using IoT system. And second one is ambulance monitoring system. Now see one serious patient is there in the ambulance. So now doctor want to monitor the patient parameters like pulse rate, oxygen level, everything. So that we can monitor through IoT system. And in pharmaceuticals production, like medicine production control and monitoring system, there also we can use IoT. These are the few example IoT in healthcare domain. And the second domain is defense system. So in defense system also IoT is useful, especially in the field of in war field. Using camera surveillance system, they can control the war crafts or war equipments. And next, radar data also we can monitor using IoT. And IoT driven autonomous defense monitoring system also there now. Even smart military asset tracking system also available. These are the examples comes under defense system. And now industry 4.0 and 5.0, that is the industry automation system. There we can see now in industry, for example, especially in food manufacturing, this one product manufacturing, everywhere IoT enabled system is there now. These are the applications of IoT. Now our topic, that IoT in smart agriculture. So we can use IoT in different modes. One is the best example is irrigation. So now that is a widely useful mode of IoT. So if you want to control, now for example, we have around 5 acres of land. You want to control entire irrigation. So we can control using IoT system. And along with that, we can monitor the next mode of IoT is soil monitoring. It's pH level, NPK level, moisture level. We can monitor using IoT. Along with that, we can third mode is weather monitoring. We can monitor the temperature, humidity, and other parameters, weather parameters using IoT system. And if you connect any camera to this IoT system, we can also monitor crops health using a camera. That also possible. And we can also do, this is the monitoring concept, say comes under controlling part. If you have a greenhouse, or if you want to control the temperature or light, humidity, anything we can control using a IoT based greenhouse system. These are the different modes of IoT in smart agriculture. So if we use this IoT system in agriculture, one is we can save water and electricity by this IoT automation. And now one of the challenging part in agriculture is labor. We can reduce manual labor and improve the crop quality, and by which we can increase the yield. And early detection of plant diseases help in improve the yield also. And cost effective farming also we can do, especially in the that irrigation and health monitoring system. If you implement in the agriculture field, that is highly useful. So these are the benefits of IoT in agriculture. Now we'll come to our practical session. Because as an industry person, my focus is on practical. The instead of theory, my focus in practical session. So we are going to give one demo that is using one tiny board, as we discussed, the tiny board ESP32. So ESP32 is one of the cheapest, low-powered development board available in the market as a IoT development board. So first, before starting the practical session, I want to give just a brief overview, hardware overview about this ESP32 board. So the in the market, especially in our Indian market, ESP32, ESP W Room 32 Div Kit V1 board is available. V2 board also available. So it is 30 pin development board. So it is a product of Silicon Labs, one company called Silicon Labs. This one Chinese-based company, and it has one tiny processor and one USB to TTL converter, and one other hardware interface parameters like analog interface, analog communication, digital communication, I2C communication, then UART communication, all other communication interfaces also available in that. Compared to Node MCU or other tiny boards, so it has more number of analog pins compared to that, and cost wise also it is effective, and the efficiency speed also more compared to Node MCU. So now other features. See, this is it has one 10 silica extensor dual core 32-bit processor with the 240 megahertz clock processor and 520 KB internal SRAM and 4 MB flash memory, and it has Wi-Fi and Bluetooth, inbuilt Wi-Fi and Bluetooth. This is the main feature of this board. And on-board switches and LED indicators is available. Enable switch is there, boot switch is there. Everything is available in that. And it has around total 30 pins. This is the pin out diagram of ESP32. So both analog and digital pins and other I2C, UART, other pins also available in that. So total 20 out of this total 25 GPIO pins. So in that few pins we can connect just as a input. We can't take output. So these are the pin out GPIO pins available in the ESP32, around 25 GPIO pins. And now in that we can see green mark and red mark and yellow mark. So green mark your top priority pins, because these pins are safe to use and highly useful pins. And this yellow mark, based on the particular requirement, we can use it. And the red mark pin is not that much recommendable. So these are the pin out GPIO pin out concept. And in that input only pins like GPIO 34, 35, 36 and 39. This one GPIO 34, the first in the left side we can see these are the input only pins. We can't configure as a output here, only input is possible, and it is a digital pin. And the pin ADC pins like around that I can show here. These are the ADC pins. Around 15 ADC pins are available. ADC means we can use it as both as well as analog and digital. So that is around 15 ADC pins are available in that. Remaining 10 is only digital pins available in that. So now around this is the DAC pins, only two pins, 25 and 26. These are DAC pins available in that. And these are the touch pins available. Around 9 capacitive touch pins are available in that. And then I2C pin. Now, if you want to connect any display or any particular sensor like NPK or pH, then we need I2C pins. So this I2C pins also available. Like here, SDA pin is there, data pin is there, clock line, SCL pin also there in that. And SPI pin is also available, especially for RFID reader and all. If you want to connect, we need SPI pins. So SPI pin also available in that. And UART pin also. This is a widely useful one, UART pin. If you want to connect with any like PLC or anything, if you need this, this UART pin is available. Even for particular sensors, we need UART pins. UART pins also available in that. Then PW pins. So these are the PW pins available in the ESP32. This is the RTC pins. these are the pin concept. These are power pins. In that 3.3 volt and 5 volt, two power pins are available and two grounds are available. One pin is 3.3 volt and one pin is 5 volt. So these are the power pin available in the ESP32. Now we'll see how to program this. The hardware configuration is over. Hardware pinout details is over. Now how to program it? So usually for this kind of board, two tools we can use. One is Arduino IDE. If you are familiar with the embedded C, then Arduino IDE is one of the tool we can use for programming. And if you are familiar with Python, we can use Tony Idle, that is for MicroPython. We can program this board using MicroPython. That is one section. So today we are going to discuss about Arduino IDE. So how to program ESP32 using Arduino IDE. So first we have to install Arduino IDE. I think most of you know how to install Arduino IDE. If you want, I can I can show it here. So usually Arduino IDE setups will be available. So we have to install the Arduino IDE setup. So Arduino IDE setup we have to install. After installation, we'll get this kind of Arduino IDE tool screen. And after that, next step is we have to configure ESP32 because ESP32 is a third-party board. See, now Arduino has its own development boards. So when we install one Arduino IDE software application, so IDE tool, only inbuilt Arduino boards configuration is available. If you want to use ESP32, ESP32 is a third-party controller development board. That's why. So we have to install all the boards required drivers or boards configuration we have to do. So first we have to install the Arduino IDE. Then we have to install a USB to serial bridge drivers. In some boards, when we install the Arduino IDE itself, we can automatically will come. In some cases, we have to install it separately. And after that, we have to go for file. Under that, you can see preference. There you can copy. We have to copy this link. This link we have to copy. I can show here. So go to file and in that preference. So we have to copy that link because in this link all the source files are available to install ESP32. And after that, we have to once this thing is copied, we have to go to board. Under that board manager, and you have to type ESP32 and we can install ESP32. So it takes few minutes to install. So in my system, it's already installed. So I'm not doing that. So and after that, we can see the screen. In that you have to select ESP32 Arduino. One option will be there that you have to select. And in that, two option is there. One is do it ESP32 div kit, one option, or else ESP32 div module. That also you can show. You can select. So I can show it here. So go to tools. In that board manager, see here. Here you can select ESP32 div module. This option also fine, or else do it ESP32 also fine. So any one thing you can use. And after that, once configuration board manager board configuration is done, then we can select the port for upload the programming. If you want to check the port, just you can type device manager. So if you go to device manager, in that in the under port section, if the device is connected, we can see the port number here. So same port number you have to select in the port option. So once it is done, then we have to we can program the ESP32. This is the basic Arduino IDE configuration for programming. So the operation modes. Now the next point is operation modes. We can operate ESP32 in 3 modes. The first one is station mode, and the second one is access point mode, and third one is HTTP or server mode. That is the global mode. So now we are going to explain what is station mode and what is access point mode. So see, now, for example, you have a Wi-Fi connection in your room or a house. So we can connect that Wi-Fi to ESP. So we can we have to give the SSID of the Wi-Fi router and password of the Wi-Fi router in our program. And that program we have to upload to our ESP32. So here host is our this one, what our router. So router's SSID and password we have to assign in the program, and that program we have to upload to the ESP32. Then this mode is known as station mode. So here our Wi-Fi network should be stable, and that it takes its IP and it works. That is station mode. And next mode is access point mode. So here we are converting ESP32 as a server, like as a router. Like we have to assign our own IP, and we have to assign our own SSID. We have to assign our own password, and that's converting ESP32 as a what as a host, that is known as access point mode. So if you want to make any local IoT system, like now inside the room, how we are connecting Bluetooth. Similarly, if you want to connect through Wi-Fi, if you want to connect to ESP32, and if you want to make any IoT system, this access point mode and station mode is preferable. So now we can show the demo related to that. So for giving demo, our topic, today's topic only we can consider, that is IoT based smart agriculture system using ESP32. For this, we need some other components other than ESP32. The required components are: one is ESP32, that is our IoT development board. Second one is soil moisture sensor. It is a tiny sensor which gives water content in the soil, volumetric water content in the soil. And third one is DHT11. There is two versions, DHT22 and DHT11. So that is Della's humidity temperature sensor, which monitors temperature and air humidity. That is one sensor. And next one is relay module for controlling the water pump. We need relay module. So we used here one channel 12 volt relay module, and one 7805 regulator for supplying the regulator. So now here directly we can power using normal data cable. So regulator is not required. So this is the block diagram. Now, as we discussed, now DH11 we are connecting to the pin number D4 data pin, and that is the power supply part. You can see here power supply. If you want to connect 12 volt power supply, this 7805 regulator or any other buck converter, anything you can use here. So just for example, I use the 7805. And if you want to connect soil moisture sensor, you can connect to analog. Here you have to take care. It should be ADC pin. Now D35 is a ADC pin, ADC channel 1 pin. If you want to connect any analog pin, you have to take care. Digital pins now directly connect to D4, no problem. And one more digital pin, relay out pin is we connected to D23, that is also digital pin. So this soil moisture pin is connected to analog pin. This is the pin configure, the block diagram of the concept. Now let's have a demo. We can now we'll connect to one more camera and we can show it. Please give me 1 minute time to arrange the demo. In between, if you have any queries, you can ask with me. It takes 1 minute to arrange the demo. So if you have any queries, you can ask with me. I hope our setup is visible to you.
No, not visible. Yeah,
No, sir.
right now visible.
Please give 1 minute time, sir. We are arranging it. You can hold it. You can hold it. Is it visible now?
Yeah, visible.
Sir, yes, sir.
Okay, I'll mute it. Now. Just it is showing black diagram, sir. Just a minute, sir. Just a minute. Now is it visible, no? No.
Yes, sir.
Now it's visible, right?
Yes, sir.
Because at a time we can connect only one camera. That's why.
Yes, sir. Visible.
So here we are using one breadboard. I think it's visible to you. We are using one
Yes, sir.
breadboard. And here we are using one ESP32 development board. You can see here. and one relay module. This is one relay module and one soil moisture sensor and one DHC. This is DH311 temperature sensor. And this one is a soil moisture sensor. So one small glass is there, in that some water is there, so I can dip in this. And this is one relay, one channel relay, and one breadboard and one ESP32 development board. So all wire connection as per this block diagram we have done now. Now I will open station mode. See now we'll execute station mode. So now in this, now I'll open the station mode. So when we have to enter the IP address, so this IP address is 192.168.37. That is the board IP of my. See now I connected my office IP net office Wi-Fi to this ESP32, and now its IP I'm writing here. So see now we can see. I think it's visible to you. So you can see the dashboard what we have designed, small dashboard. So here 3 mode of operation. So here you can see the present temperature, humidity, and soil moisture level in this, and the status of the pump. Now pump is not there, so now we'll consider relay as a pump. Like relay is the switch. So now status of the relay is off. Now if I click on here, so now relay should on. It takes few seconds because of the internet connectivity. See, now relay is on. You can see a light in this. Relay is on in this. You can see the light. Now here also status updated to relay is on. Now I'm connecting stop. Now if I connect stop, so in few seconds, takes few seconds because communication should take place. No. Now relay will off and here status will update to off. Okay. Now second. Internet issue then it's off. It's off now. This is one demo. Now one more mode I want to show. Second mode we are going to show now, that is auto mode. Give me a few seconds because here some internet issues there. We are correcting it. So now you can see here, now we are moving to auto mode. So here you can see the soil moisture level, that is 60%. So I have given around 65 minimum threshold and I will save the threshold. Now here he inserted the soil sensor to the water. Now here soil moisture is increased. It is around 100%. Now he will remove the soil sensor. Now see, soil sensor is 0. Now you can see relay is on. Means it is automatically pump will on. Now again he'll dip. Now see, soil moisture is above this minimum soil moisture level. So relay is off. This is auto mode. And next mode is a timer mode. So timer mode, you can set the time like start time and stop time. Now start time is 8:08 I'll give, and it is PM. And the stop time 8:10 I'll give, and I will activate this module. Now see the mode has changed to timer mode. Now here timer started. So within 5 minutes it should on. So here in three way we can control this IoT system. One is auto mode, manual mode, and uh, timer mode. Actually, it is one. Actually, we have one product, our own company product we have. So the demo of that, this is a one tiny demo of that. The real product demo I'll show you after this. So we have used station mode. Station mode I already explained. We have to take Wi-Fi, SSID and password of our local Wi-Fi router. You can use mobile hotspot also, not a problem. If you have Wi-Fi connection in your home, you can take that. And based on that, this device will work. That is station mode. And next mode, access point mode. After this, I'm going to show that. I think it is visible. This video is visible for all, right?
Yes, sir.
Yes. Now, in few minutes, it's going to on. So that time you can see, I can explain the flow charts here. Same concept, two modes, auto mode, manual mode, and timer mode. So the entire flow chart explains the workflow of this project. So even in agriculture field, see how this mode useful, I'll tell you. So if you are some, for example, I'm a farmer, I have some busy schedule. I can set the threshold level, like minimum soil and temperature level I can set. And based on the level, soil level, moisture level and temperature level, this device will work. That is auto mode. So now I am free. So I want to control manually. Then I can go for manual mode. So manually I can control the device. And if I want to, based on the timer, now, for example, in certain places, only in this time water is available, means we can set the time, start time and end time. And based on that, we can control the pump. This is the three mode of operation. And here we have used only DIY based components. It's not industry based components. So if you want to convert to industry, many different changes we have to do in that, because industry grade is different. Our DIY grade is different. So it is DIY, just hobbyist purpose we can use this. Even we can make it as a product, but it is not ISO standard or industry grade standard. For industry grade standard, we have to use some other standard components. Relays and all same we can use. Now, for example, one thing I can explain. So DHT11. DHT11 is not an industry grade temperature. If you want industry grade, you have to go for DHT22 or other temperature sensors. Now, soil moisture, what we have used is a basic soil moisture sensor. It is just one two terminal is there. Now you can use capacitive soil moisture sensor if you want to industry grade. And relay, same relay we can use. So these are the components what we have used in this project. Now within 2 minutes, this relay should on. This is timer mode. So I will please wait. I will arrange one more demo. That is our live product. So please wait for 2 minutes. See now, takes few seconds. Please wait. if you want to work the same, see now if you even instead of ESP32, you can use Raspberry Pi or other development boards also. The work mode will be different because in Raspberry Pi we have to install Raspbian OS or any Ubuntu OS we have to install. Then we can program using Python. Easily we can program it using Python, or else any Java based concept also we can use in that. So that is the Raspberry Pi. So Raspberry Pi programming concept is entirely different, and for that live session we have to take. Now see our timer is see now relay is on. So here it is 0, relay is on. You can see here. Now around it takes after 10 minutes it will off. So time due to time limitation, I am not going to show that. Now this is working in the timer mode. I think you understood what is auto mode, manual mode, and timer mode. So now same kind of one device is there that I'm going to share you now. That is our IoT smart timer. It is one of our live product. It is hosted in our server. So we used the Bluehost server for this. This is our next mode, that is server mode. So we used our Bluehost server, and in this is a cPanel of that. So I hosted a PHP file. So I use just a PHP file for developing the PHP for developing the web page. This is the code of that, and this is the small dashboard of that. Here also same. This thing is live. Even you can use it. I will share this link in the Microsoft chat. Now, see, I request anyone. Hello, I'm audible.
Yes, sir. Yes, sir.
Yes, sir.
So anyone, please. I think this URL is visible.
Yes,
I can't
sir.
share it. This URL is visible, right?
Yes, sir. Yes, sir.
So please
Yes,
share
sir.
your screen and type smarttimer.kakunjesoftware.com. Anyone, please share your screen. Because from your place, we can control the device. Please type smarttimer.kakunjesoftware.com. Open any browser. I think our device is visible now. This is our device. Here I connected one bulb. This is our device. Smart timer. Smart timer without space. .kakunjesoftware.com. .kakunjesoftware.com. AAKUNJE software.com. Smart timer. ER. R is missing in that. Software
Correct,
spelling.
sir.
Software. You can remove that. Yeah. Enter. Please enter. So we can see our dashboard there. And username is admin. Password is 123. Username is admin. And password is 123. And log into that. Now network. Yeah. See now it is once you dashboard comes, our device will on. Now device is on. The initial mode is on.
Yes,
Now
sir.
due to internet The dashboard will come. Please wait for a few seconds.
Okay, sir. Okay, sir.
I think some internet, see, the dashboard will be like this. And if I click on here, now here device should on. Plus multiple. Yes, yes, that is the problem.
Nothing will showing, sir.
Just a minute, just a minute.
Okay, sir.
It's see, now I pressed on here. Or our device is on. Now if I
Yes,
press
sir.
off, device will off. Same thing should work in your dashboard also. So please
Okay,
check your
sir.
internet connection also properly.
Okay, sir. Thank you. Now stop
Same,
sharing.
same. Yeah, you can share. You can stop.
Okay, sir. Thank you.
Okay. So this is the IoT concept. So we can control and monitor any devices using through internet using this kind of development boards. So this is my today's session. So if you have any queries, you can ask with me.
Sir, please share your email ID and contact number
Okay, okay.
in
Now
chat.
only one.
Sir, I am working on the plant. That is why I needed many sensor for monitoring
Okay.
plant health.
You can scan this QR code and you can take my details.
Once, sir. Thank you, sir.
And due to see in online, we have more IoT products related to agriculture only, but through online it's difficult to show. So if you have any live sessions, we can do that.
I can contact you.
Yeah, sure, sure, sure.
Okay, sir. Thank you.
Good evening, sir. Hello, am I audible?
Good evening.
Sir, my name
Please,
is
please, sir.
I'm Professor Chakradhar, working in Ramchandra College of Engineering, Eluru district, Andhra Pradesh.
Okay.
I'm working in CSE IoT department since past 5 years.
Okay.
My research area is also IoT. Still now we developed a number of prototypes.
Okay.
And we are converting them into real life applications.
Okay.
As just you have shown that smart agriculture, smart irrigation system especially. We developed one real-time applications 1.5 years back. We are using it in our college. The management has given 0.4 acres of land. As you said, you also developed a real-time application.
Yes.
Have you taken weather prediction while you are considering it in consideration?
Weather prediction also possible. For that, we have to use other sensors like NO2 sensor or cup anemometer, like for wind speed.
Okay. Or
So
else we
different
can,
sensors are.
or else we can
Yes, sir.
consider Google weather prediction, which is given by the Google for past coming 15 days. So that can we consider?
Yeah,
Because,
Google prediction, Google API is available that we can integrate with our dashboard and we can do
yes,
that.
sir, yes, sir. Yes, we
But
interface it, sir. Actually,
if you need precise data, like precise weather prediction, then our own weather sensors we have to use and we have to connect to our controller unit, and through that we have to monitor.
Yes, sir. Yes, sir. Actually, we faced that problem, sir. Actually, based on soil temperature, moisture level, we are giving the water. On a
Okay.
sudden, maybe after giving the water, maybe rainfall in the couple of hours or next day, maybe it should
Okay.
affect the crop yield. That's what. We are also
Okay.
working on that to integrate the
No, for
weather
weather
prediction.
prediction, different sensors are. So the main thing is wind speed and this temperature we have to monitor,
Okay.
and humidity levels. Now, if you use the DHT22 sensor and cup meter sensor, that is available in online also, you can purchase it.
Yeah. Okay.
And we can check the humidity and temperature level, and based even you can Google API also, you can integrate.
Yes, sir. We integrated Google API, sir.
But Google API
Yeah.
prediction is not 100% accurate. No.
Yes, sir. That's what I'm asking, sir. That's what I'm asking.
So better use your own sensor system like sensor unit, and can connect it to your control board.
Yeah, sure, sir. Thank
Which
you.
controller?
But
Which controller you are using? Which development board you are using?
we are using Raspberry Pi, sir.
Okay, but Raspberry Pi, instead of Raspberry Pi, ESP32 is my suggestion is ESP32, because Raspberry Pi is very costly board. If you want to make it as a product or long run concept, Raspberry Pi is very costly. So if anything happens to the board, you can't afford it. No.
Yes, sir. Yes, sir. Yes, sir.
So that's why my suggestion is ESP32, and easily you can program, and it is reliable. This product is reliable.
Yeah, yes, sir. Yes, sir. I know it.
And if
One
you
more, sir.
make it if you want to make it industry grade, then you have to go for STM or Nordic or Note and other microcontrollers, other development boards.
Okay, sure. Sir, we are also working on fully automated solar dryer system.
Okay.
Already we established the AI-based solar dryer system. In our college only we established it with the support of the
Okay.
management. And
Okay.
now we are working on one thing, sir, to know the moisture level in fruits and vegetables, which we kept in
Okay.
the solar dryer.
Okay.
For that, we are working
You
on
want to reduce the moisture level, right?
all solar dryer is for reducing the moisture level, but we want to
Yes.
know how much level of moisture is reduced without physical visit.
Yeah,
Through
you can
app
use
only.
moisture. You can use humidity sensor and moisture sensor. No, there.
No, sir. Moisture sensor we need to insert into the fruit, na.
Yes.
But
Your
we are
atmospheric moisture level you want to calculate, right?
that will give the room temperature or a dryer temperature.
And
But we
humidity level
want,
also, if you can based on humidity also you can do it, no?
yes, sir. But we want to know the fruit moisture level.
Fruit moisture
Maybe
level you want to know.
fruit or vegetable moisture level, how much percentage it is dehydrated. That's what we are working on.
Without any sense inserting any sensor, right?
That's what, sir. Is there any possibility? I'm asking.
Possible. You have to use a thermal camera for that.
Thermal camera.
Thermal camera will check the when we use thermal camera, we can classify like hot body and cold bodies.
Okay.
If moisture level is more than the camera's image color will change.
Okay.
Based on the color, we can predict. Now, low cost thermal cameras also available for 4,000 to 5,000 rupees. Thermal cameras also available.
Okay. Where we can find, sir, these thermal cameras?
Now, I can robo.in one website is there are many online. If you want, I can share it. You can take my number. I can share the links.
Sure, sir. Sure.
And
I
using
will
Python, see that camera you can connect to Raspberry Pi directly, and using Python you can program it.
Yeah. Sir, actually, we are working in around 18 to 19 agriculture related applications purely.
Okay.
We are working on real-time applications.
Okay.
So that I need some sort of guidance and help.
Sure. You can contact
definitely, I will contact you, sir. Just now you
Sure.
have given the QR code.
Yes.
So through that, can I contact?
Yes, sure, sir. You can WhatsApp me.
So your good name, sir?
My name is Gopal Krishna Bhatt, GK Bhatt, Kakunji.
All right, fine. Thank you very much, sir. Thank you.
Thank you.
I will contact you, sir. Thank you.
Sure. Thank you so much. So if any queries, please ask. So this is the one of the PCB board, double layer PCB board, what we have designed for our for this demo. This is the schematic of that. So here we used relay and ESP32 board and 7805 regulator, soil moisture and DH11 sensor. You can connect it. This is our small development boards. And you can see our one more the product what we are selling, IoT product. In the camera you can see this is one of the product what we are selling. This is IoT switch. Like we can control same things what we have explained for agriculture purpose. If you want to control any water pump or anything, we can use it. Use this device, the IoT switch. And same concept here we used ESP32. But now this is our first version 1. In version 2 we are using STM. We are not using ESP32. We are using STM. STM is little costly, but our most of the clients are from overseas clients. They expect some standard quality controllers like STM. So we ship to ESP32 STM because ESP32 is a purely China based controller. Any other queries, please ask. Or if anything to discuss related to IoT, you can discuss now.
Good evening, sir.
Good evening.
Sir, this is Karthik from Kongu Engineering College, Tamil Nadu, Erode district. So actually,
Okay.
my research is to identify or detect the plant infestation. So
Okay.
is there any specific sensors are there for to identify this infestation apart from that MQ sensor?
Is it wireless or how you want to? Can we insert anything to that?
Wireless, sir. Wireless, sir.
Okay. One is NIR sensor is there. NIR.
NIR. Okay. Okay, sir.
NIR sensor is there. That is based on IR
Okay.
rays. That you can in that
Okay,
different
sir.
grades are available. Different grades are available. So if you use
Okay,
that
okay,
NIR sensor, we can check the chemical properties of any object, any living object.
Okay, okay,
So
okay,
that
sir.
it is a little bit costly. It's not available in India. We have to import it.
Okay, okay. Sir, approximate cost how much, sir?
Actually, yeah, approximate cost up to 30 to 40,000 rupees.
Okay, 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 sir. Okay, sir.
And I can share the link if you want.
Yeah. Yes, sir. I will ping you through the WhatsApp, sir.
Yes. And using AI and all, you can do only limited concept if you're using image.
Okay, okay.
Better you use the sensors only for that.
Okay, sir. Thank you, sir.
Okay.
Sir, is it possible to monitor the real-time soil quality by using
Soil quality
stainless
possible. We have NPK and pH sensor for that. Even we have one soil quality monitoring device. So in that NPK value and pH value, we can monitor live. We can do monitor that. One product we have.
Okay, sir. Okay.
That also within 15,000 we can develop it.
But in
Pardon, sir. I can. Hello. Yes. Any queries, sir?
in real time, actually for soil testing, they use dry soil.
Yes. You have to take samples from different points of your your field. Only one. See, this is pH sensor. You can see in the camera. As in the preview, this is the pH sensor what we are using, and NPK sensor is available. That also I can show you.
Okay, sir. Okay.
This is pH electrode. The sensor is inside the module is inside the board. We have to connect. Using this, we have to connect.
Okay.
If you need any guidance, we can do because we have tested the product. We have a license also for that.
Okay.
Any other queries?
Sir, can you please provide your email ID in the chat box?
Yes, yes.
Hello.
Chat
Phone number
box.
also. Possible.
Just a minute, sir.
Hello.
Yes, yes, sir.
Hello. Sir, this side Professor Dr. Naveen Rati from HRIT
Yes,
University, Ghaziabad, Uttar Pradesh.
yes, yes.
Actually, sir, we are developing a hybrid agriculture system.
Okay,
So it's basically we are designing a sort of robot
okay,
where it is taking care of all the necessary activities, maybe weeding, plowing, and then tracking the plant disease also. This
okay,
is something which we have integrated four robots, four
okay,
multiple decisions to be taken, and then we are controlling it through one control system, which is a sort of a web page which we are designing. This is basically
okay, okay,
a research scholar activity,
okay,
and it has been funded by Council of Scientific and Technology.
okay,
So my query basically is since you have been showing the demonstration of different sensors which you are using, maybe
okay.
soil moistures and all. My objective is, sir, can we design a sort of using AI tools for making a model, and then we can interface different API so that the data breaching is being avoided using the cloud
Possible,
systems in.
possible, sir. We can convert a model to API. It's possible.
We can convert it into API because
Even
my query.
say if you using this ESP32, what I have shown on development board,
Yeah.
we can make tiny AI models and we can upload to that board and we can use it. In that, one more ESP32 CAM module is available.
Mhm.
So using
Okay.
that, we can do real-time projects.
No, because for detection of the images, we are using YOLO
YOLO V8 or V11?
V11, sir.
V11. Okay.
Yeah, we are
So
using that
see,
for capturing the images.
you can convert it to API. Your model file is there, no?
Yes, yes, yes.
Using Python script only, we can convert into API. It's possible.
It is possible, no?
Yes, yes, yes.
So can I have your email ID, Professor, so that I can interact with you?
Yeah, I already shared, sir. Is it visible to you?
Just a minute, sir. Let me capture it, sir. Give me a moment.
And my mobile
No, I
number also,
can share.
WhatsApp
I
number.
will share in the group.
You can share it in the chat if it would have been possible.
I will share in the group or the chat here.
Right.
Surely I'll share.
Thank you, sir, for sharing such a valuable
If,
inputs. Thank you so much, sir.
thank you, sir.
I'll get in
Thank
touch
you, sir.
with you.
Sure, sir. For any artificial intelligence, quantum computing, mechatronics, electronics, embedded system, AI, any
Right.
full stack, one stack, anything you can contact. We are into hardware and software both. VLSI
So
also.
you're located at which place, sir?
I'm from Mangalore.
You're from Bangalore. Okay. Right,
Yeah,
right,
yeah.
right.
Mangalore. Not Bangalore,
Okay, sir.
Mangalore.
Right, sir.
Actually,
Right. I'll get in touch with you.
I'm alumni of Canara Engineering College.
Okay. Right, right, right. Because basically, I have been involved in this agriculture systems and smart cities with the government
Okay.
of India. So that's why I'm talking regarding it.
So please,
So can we?
connect with us, sir.
Yeah, for sure, sir. For sure. Thank you so much. Thank you so much.
Actually, we have one of the overseas client from Riyadh Green, one Saudi.
Okay.
So they are converting this desert to now veggies. Like they are cultivating
Okay.
plants there. So
Maybe
they are using
artificial
all
soils
this
they will be
IoT
putting.
system. Yes.
Mm, right, 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 right. Okay. Right, sir. Right. Thank you. Thank you so
Thank you,
much.
sir. Thank you so much. Any other queries?
Thank you, sir.
Any queries, sir?
So this is my email ID and mobile number. And if you can visit my office also, I can. If anyone want to WhatsApp, this is my WhatsApp number. I can share my office address. Here you can see our live demo experience, like our experience room is there. So there you can see the live demos of our all products. And if you have any problem statements, if you need any research assistance, you can contact me. Or if you want to, for example, you have one prototype, you want to convert as a real-time product. For that also, you can contact me.
Sure, sir. Thank you very much.
Thank you, sir. Thank you.
Sure.
So, ma'am, shall we wind up?
Yes, sir, we can wind up. Thank you very much, sir, for sharing your expertise, and it was a very helpful session. I think all the participants have gained very much insights from your session. Thank you very
And
much,
even
sir.
it's for
And
me
I'll be
also
sharing your
one good experience.
details.
For me also one good experience, and to have discussion with the senior most professors and faculties. And once again, I would like to thank Canara Engineering College for giving this opportunity. Thank you so much.
Thank you very much, sir. Thank you, sir.
Thank you, sir, for
Participants,
your
tomorrow.
valuable information.
So we'll be winding the session, and tomorrow's session it will begin at 6 p.m. And tomorrow we'll be having a session by Dr. Gurraj HL, and also one of the industrial person, that is Mr. Tirupati. So who will be discussing about IoT in means cyber security along with IoT concepts. Thank you very much. Have a nice day.
Thank you. Thank you.